Pre-cal babies, it is time to learn how to graph our sine function. So that's what this video will begin explaining. So before we get started, I want you to recognize a couple of things. The first thing is that if your equation contains x, that means we're going to be in radians, so the x-axis is going to be marked in radians. And if your equation has theta, that means we'll mark the x-axis in degrees. The other things we're going to need to do, we're going to need to look at the equation, and then we're going to need to list our amplitude, period, shifts, and reflections so that we'll know how this graph is going to look. Okay, so having said that, let's jump in here, and I am just going to switch colors. So we've got our first equation here, y equals 2 sine theta. So the first thing we need to recognize is that this equation is in degrees, and there's no reflection, so we don't have to worry about that. The amplitude is going to equal 2 right there. So we've taken care of that, and degrees. We need to know the period. Remember that the period for the sine parent is 360 degrees, and since there's an understood 1 between sine and theta, that means that this is also going to be 360 degrees. So that means that we are going to, it's going to take 360 degrees to graph a single period or a single cycle. So we're going to graph 2 cycles. So that means that on the right side of the y-axis, I'll have 360 degrees, and on the left side, I will have 360 degrees. Okay, so these graphs look a little different than your standard XY coordinate plane. It doesn't mean that the graphs will be different, it's just the way we graph them will be a little different because I've set it up so that you've got your x-axis here just to make it a little bit easier, and you're going to see what I'm talking about in just a minute. Okay, so the first thing we're going to do, we do not have any right-left shifts or up and down shifts, so I'm going to start by including my y-axis. And I want you to notice I've labeled x and I've labeled y just like we normally would. And then, of course, for the y-axis, I'm just going to make some marks here. And then on the x-axis, I'm going to try to, as evenly spaced as possible, mark out 4 spaces. You're going to see why in just a minute. I'm going to do the same thing to the left of y. Okay, now we already talked about this idea that the period is 360. So that means to the right of the origin, I'm just going to break this up into fourths. And these values should look familiar to you because they occur on the unit circle. Okay. Once we get that, now we have to think in terms of our amplitude. Well, the way I've labeled the y-axis, this would be 1 and this is 2. So my amplitude tells me that my graph will peak at 2 and trough at 2. So the way this is going to look, since it takes 360 degrees for one cycle, remember one cycle is 1 up, 1 down. So to the right here, I'm going to do this. My graph is going to peak at 2, it's going to go through 180, it's going to trough at -2, and then come back up to 360. And if it helps, you can make little dashed lines here so that you can make sure that your amplitude can be seen clearly. And then, of course, on the left, we are going to do the same thing. This is going to trough at -2 and peak at +2. So again, you can use dotted lines to help you guide yourself. So that's pretty much all there is to that. That graph is completely done. All right, so let's go to the next one and see if it is going to change a few things. So as you can see, our equation's a little different already. We are still dealing with degrees, because we have theta right there. But let's look at some other stuff that's going on here. This -2 means that the whole graph is going to shift down 2, so that's going to be important. We'll need to pay attention to that. Notice we've got a negative here. That means we are going to have a reflection. And then 4 tells me that my amplitude is equal to 4. And the other thing I need is the period, and since there's no value between theta and sine, that's just going to be 360 degrees. So the very first thing I'm going to do, I'm going to start with my y-axis. I'm going to label it. I'm going to label the x-axis. On the x-axis, I'm going to go 1, 2, 3, 4. And since the period is 360 degrees, that's what that's going to look like. All right. Sorry, this takes a while. Okay, so that's what we have for our x-axis. So we've taken care of the degrees, and we've taken care of the fact that the period is 360. So now we have to talk about this reflection, moving down, all that jazz. Okay, so when you think about moving down, that means that rather than starting at the origin now, I'm going to be looking at starting here, okay? So that's what that tells me. Now, the amplitude is 4. So that means from this center point right here, I'm going to have to measure, see, there's my dotted line. That'll show me where to stop my graph. And then I've got to do the same thing below. And I almost ran out of room. Okay, so that just gives me an idea of what my graph is going to look like. All right, so that takes care of my amplitude. Now I've got to consider my reflection. Well, this is the sine graph, so normally it would go like this, right? It would go like that from your starting point. But since we have a reflection, it is going to do this. Okay, oh, I hate it when it does that. Sorry, with the straight line, I don't know why it does that. Okay, so it's gonna look like this. Okay, so that, I just want you to kind of get in mind what that's going to look like. So now what happens is we're troughing at 90, and then what we're gonna be doing is coming all the way up and going through, oh, that doesn't look quite like I want. So we're going to be peaking there, and we're going to be coming down to 360 right here. So you have to kind of think of this as my new middle point here. So you have to think of these values for 360 right here. Okay, so I know it looks funny, but anyway, hopefully you'll survive this madness that is Miss Griggs. We don't know. You're a freak. I know, kids. Okay, so it would look something like that. And see, since we moved down too, that's why the whole graph is kind of just scooched down. That's why it looks that way.